Hi guys, I'm Rushian. This video is all about how I gained knowledge on a microprocessing element and what are all the problems I faced in gathering the information. Let's start. Yeah, this is a brief information about me and the course this assignment belongs to. My name and my registration number, and computer organization and architecture is a course which this digital assignment belongs to, and this is the course code of the course, and I'm doing this course under faculty Danbal sir. Coming to this DA, what does this DA is all about? As I said earlier, this is all about gaining knowledge about a microprocessing element. And how did I do that and what are all the problems I faced? This DA is all about analyzing a microprocessing element. The microprocessing element which I chose for this assignment is one of the microcontroller from PIC18 family. This microcontroller produced by Microchip Technology. Firstly, how did I start to gather information? For any IC to get information about it, the main requirement is from its datasheet. So I gathered the datasheet of my IC, and also I used some other online sites to get additional information about my IC. This is the link of my IC's datasheet which I used to answer this assignment. Okay, then coming to the questions asked related to this digital assignment. Firstly, to draw the clear block diagram of the microprocessor, microcontroller and or IP core selected. As my chosen IC is a microcontroller, I answered this question using the datasheet related to my IC. And I use this online site known as Draw.io to draw the diagrams virtually. Coming to the digital assignment, first question is to draw the block diagram of microcontroller. This is the block diagram of my microcontroller, and this is a pin diagram of it, and these are all the internal diagrams of my IC. To draw these, I used an online site known as Draw.io, which is very easy online tool to draw flowcharts and block diagrams. And after we can choose the symbols which we want easily, and we can draw flowcharts and we can export them in any form we like. Problems I faced while answering this question is, as I used Draw.io for the first time, it took much time for sketching the diagrams. So the time taking is the only problem I faced while answering this question. Coming to the next question, they asked to provide the instruction set of my microprocessing element. For this, I use my datasheet to answer this question. My datasheet has an instruction set of my IC, but the main problem is to identify what are all the different types of instructions given in this instruction set, and accordingly we need to answer this question. First of all, I differentiated types of register instructions given in my datasheet. In my datasheet, there are like byte oriented register instructions and bit oriented, and also control operation instructions and literal operation instructions, as well as data memory, program memory instructions. So first of all, I differentiated them and tabulated them using Excel. Next question is to explain about microprocessing element architecture. Coming to my IC's architecture, I did not find much information about architecture related to my IC in datasheet. So I found out an online website tutorials point where I found the information related to architecture, that is Harvard architecture. And by knowing the architecture, I started to gather information and block diagram related to it, and again I used the online tool Draw.io to draw the block diagram. And coming back to my DA, this is an Harvard architecture based model, and my microcontroller follows this architecture. This is the information which I gathered from tutorials point and block diagram from online sites, and I used Draw.io again to draw this block diagram. Problems I face while answering this question is nothing but a small confusion while knowing the information about architecture, because before referring to the tutorials point, I referred to many online websites. So there were like different opinions and different information about an architecture. So there's a little bit confusion while gathering the information about my Harvard architecture. Next question is to correlate the microprocessing element architecture with architectures discussed in our module 1 and 2. Yeah, this question can be answered if you have total knowledge on architectures which are discussed in module 1 and module 2. Yes, in module 1 and module 2 we discussed about like IAS architecture and von Neumann. So I prepared notes about those architectures prior and compared it with my Harvard architecture. Coming back to the DM, this is the fourth question, that is correlating the microprocessing element architecture with the architectures discussed. Yeah, This is how I made notes on von Neumann architecture, and Harvard architecture. I got the information about it from online websites. So I differentiated it with von Neumann architecture. These are all the basic differences between these both architectures. These are the block diagrams of von Neumann architecture and Harvard architecture. Von Neumann architecture model, I got it from like slides which I referred for module 1 and module 2 preparation, and Harvard architecture model I found it from tutorials point. So again I used the Draw.io site, which is very easy tool to draw these architecture models. Fifth question is to elaborate register organization of microprocessing element. My datasheet has register organization for each and every bank as well as CPU operations, but it is very important to differentiate like CPU operating registers and as well as registers which are for like each and every bank, because in our datasheet we'll have many registers related to each and every bank. So coming to my datasheet, this is my datasheet which has register summary. These are related to C. These are the CPU based registers, and as well as these are for like these are all CPU based registers, but we also have bank registers which will be like these are all the bank based registers which for each and every bank. These are will be in hundreds for every IC. So it is better to find CPU based registers and answer this question. This is some information which I got from online websites related to CPU registers of my IC, and this is from datasheet. This is all the CPU registers which I took from my datasheet, and this is about the status register, detailed information how the bit variations will be while in status register. Sixth question is to explain the type of algorithm used for signed or unsigned calculations. I identified the algorithm from my datasheet only for like unsigned multiplications and signed multiplication, but for addition and subtraction there are no information related in my datasheet, and flowcharts for respective algorithms are gathered from online websites. Into my DA, this is how I tabulated the results of unsigned and signed multiplications, like cycles which are required for these operations, and this is the algorithm which is present in my datasheet for unsigned and signed multiplications, and these are the flowcharts which I took from online for the algorithms for multiplication and division. Main problem I faced while answering this question is understanding the given algorithm. The algorithm which is present in my datasheet is not similar to that of like basic Booth algorithm or other division or multiplication algorithms. So it is the problem which I faced while answering this question. Seventh question is to find what type of control logic unit is used and correlate its performance. For this question, I searched many websites for the information related to the control unit, because in my datasheet there is no information related to control unit which is used in my IC. So from an online website known as Electronic Spot and Electronic Hub, I found the my microprocessing elements control unit, and while correlating it with my modules control unit, which is there are two types of control units, hardwired and microprogrammable control unit, which are discussed in module 3 of our COA syllabus. So first of all, I noted the information related to those both hardwired and microprogrammable microcontroller units, and then I correlated it with my microcontroller unit. In my IC, we used a hardwired microcontroller, so I differentiated it with a microprogrammable microcontroller unit. So after gathering the information which is required, I tabulated the differences between hardwired microcontroller control unit and microprogrammable control unit, and a bit of information related to hardwired control unit, and I searched for block diagrams of hardwired control unit and microprogrammed unit from tutorials point, and I used again Draw.io site to draw these diagrams, and I tabulated this in Excel. The main difficulty I faced while answering this question is there is no there is a lack of information in my datasheet related to control unit. So while searching for the information related to the hardwired control unit, it took a lot of time for gathering the information. Eighth question is to explain the memory management system and in the processing element, and also listing the addressing capabilities. Memory organization for my IC is available in datasheet, but main problem is differentiating the different types of memories and memory organizations and addressing capabilities. This is PIC18 memory organization, and this is a block diagram how the memory organization takes place. And these are the two types, that is like program memory and data memory in my PIC18 microcontroller. And this is how the data memory organization look like. And these are all the addressing modes related to my PIC18, that is register direct and immediate mode and inherent mode, indirect mode. And these are the advantages of memory organization in Harvard architecture. Main problem I faced while answering this question is in gathering the block diagrams of memory mapping techniques, because there is no much information about memory mapping techniques in my datasheet as well as online sites. So it took a bit of time for gathering the block diagrams. Ninth question is to elaborate the pipeline and parallel processing capabilities of the unit and also hazard management technique. My chosen microprocessing element does not have parallel processing technique, like it doesn't support parallel processing technique. And I found an international journal for gathering information related to pipelining and hazard management technique, and also some information from tutorials point. Coming back to DA, this is a small information, like basic information about pipelining and stages of pipelining. That is instruction fetch, decode, execute, and memory access and write back. This is my pipelining technique in my PIC18 microcontroller. This is how the stages look like. And as my microcontroller does not support parallel processing, this is the just a few basic information relating to parallel processing and types of parallel processing. PIC18 parallel processing, however, it does not support directly, but it has some multitasking ability features. So these are all the 5 multitasking features which comes under multitasking ability of my PIC18 micro. This is a block diagram of multitasking of my PIC18 microcontroller, and this is about hazard management technique, different types of hazards, that is data hazards, and methods to deal the data hazards, and these are structural hazards and control hazards. These are different types of hazards and how methods to deal with them. The main problem I faced while answering this question is, as my IC does not have parallel processing technique, it was a bit tough while stating information about hazard management. 10th question is to find whether processor level parallelism is available in the elements selected, and also about the cache coherence. Of course, my microcontroller does not have parallel processing. And coming to the cache coherence, datasheet of course doesn't have cache coherence information. So I found it from online sites and also from tutorials point. Coming back to the DA, this is the information about cache coherence, and this is the method which I found from tutorials point, and I used the Draw.io to draw these diagrams. These are all the protocols used for handling hit or miss, and this is an example for one of the protocol, that is Snoopy protocol, and this is how the method like Snoopy protocol works. And these are all different types of cache unit events and actions, that is read miss, write hit, write miss, read hit, and block replacement. And this is another type of protocol, that is directory based protocol. The main difficulty I faced is in knowing the hit and miss concepts and gathering information about it. So this is how I answered these all the 10 questions related to my IC, and thus information about my IC provided by above questions.